coefficient of determination, R squared. By the way, I have had students do this before, so let me just give you a heads up. If I ask for a definition of R squared, do not think that telling me R squared is R times R is going to be adequate. Yes, R squared is R times R, but that does not help anybody to understand what R squared means. All right, so let's go over this definition, and I'll elaborate a little bit, and hopefully, this will make sense to you. So if we just look at this particular definition I have up here, R squared measures how much of the total variability of Y values is accounted for, explained, or predicted by X. If multiplied by 100, this tells you the percentage of the total variability of Y explained by X. But notice that we're not saying it's caused by X. We're just saying, okay, well, this explains this amount of variability. All right, and so in this sense, R squared is the measure of effect size in correlation. All right, so we need to break this down and go through some examples so that you'll understand. All right, so the first example, why will some people score high on the final and others low? So in other words, we're trying to explain the variability in the scores of the final exam. Right? Because certainly not everybody's going to get 100%. There's going to be variability there. So let's call that the Y value, all right? The Y variable, all right? The scores on the final exam. So why do you think those scores are variable? Well, you can probably, off the top of your head, think of, how long did they spend studying and preparing, right? That certainly would likely contribute to why some people score high and others not so much. Maybe you want to look at motivation to do well. Maybe some people are at the point where they're like, you know what, I just don't care anymore. My sanity is worth more than scoring high on this final exam. Maybe you want to look at their mood when they're taking the final. Right? Maybe some people are in a good mood and others not so much. How about whether or not they have been doing all the practice problems and et cetera, et cetera. So there's lots of reasons why somebody would score high and others score low. So if we pick just one reason, we might want to look at time spent studying. And if we look at that one reason, what we're going to do, we're going to calculate the correlation, the R value, right? We're going to look at the R value between the time somebody spends studying and their final grade. We're going to just calculate the correlation between those two variables. Now let's just pretend it equals 0.50. That's the R value, not R squared, that's the R. So how much then of the variability in the final grade scores is explained by study time? How would we calculate that? How do we figure that out? Well, all we have to do is take this R value and square it. So 0.50 times 0.50 is 0.25. And if you multiply 0.25 by 100, you get 25%. So what that is telling us is that 25% of the variability in final grades is explained, accounted for, or determined, predicted would be a better word actually, explained, accounted for, or predicted by how much time people spent studying. All right. Notice I didn't say it's caused by how much time people spend studying. We haven't determined that. Remember, we talked about how correlation is not causation, right? But what we can say is that the time people spend studying explains 25% of the variability that we see in their test grades. Okay? So if 25% is explained by study time, how much is unexplained? Well, simple math. If 25% is explained, that means 75% is unexplained. Now you might think, well, we came up with all these other variables. Yes, you did, but you didn't measure them or study them. So we're just going to chalk them up and group them together as unexplained. Okay, they are part of the unexplained, part of the equation, and we can do further studies to see how much they contribute. All right.